Hi guys, today we're going to be working on finishing up the density of plastic polymer data sheet that we started last week with the Plastic Density Lab. This will be a two-part video series. The very first video that you're watching now is going to be on how to finish the worksheet, and when you are done with that, you will take a picture of that and upload that onto Google Classroom. Part 2 is going to be on creating a spreadsheet. So we'll take this information, we're going to create a table, and we're going to create two graphs and talk about those two graphs. So let's get started with video 1. The first thing I want you guys to notice is that when you guys chose your liquids, when you put them into the table, you should have put them in order of lowest to highest or highest to lowest. So you should have had some type of order there. That order is really important because it's going to allow you to find the trends on the upper and lower density ranges that some of you guys were a little confused with. So let's kind of bring some attention to that. We are going to see right here, I have my plastic density. And then when going this way, I want you guys to notice that I have my mineral oil at 0.87, corn oil at 0.92, water at 1.0. And again, we want to notice that I put the water right in the middle here so that I'd be able to find it. As my midpoint, I have dish soap at 1.06 and pancake syrup at 1.37. Some students have asked me why I chose the liquids that I did. Water, I told everyone to choose because that is a good midpoint at 1.0. As for the pancake syrup, I chose that one because that was the highest liquid density that we had. So I wanted to make sure I had that upper range. And for mineral oil, I did choose that one kind of consciously. I chose that because when I researched my other plastics, I found out that they had higher densities than the lowest liquid, for example, alcohol. And so I really didn't need that extra low density there. So I chose mineral oil because it was the closest low density to our lowest plastic. And our lowest plastic was polypropylene at 0.9. So I wanted something that was just slightly lower than that polypropylene. Okay, so that's why I chose mineral oil at 0.87. Now, if you didn't choose these liquids, that is totally okay. If your liquids were different, as long as you have water and you have two high ones and you have two low ones, you were okay. And even if you don't have two high and two lows, just go ahead and go with what you have. And as long as you tell me later on in the explain section what mistakes you made, you'll get your credit back. So no worries there. Now, if we look at the little part of this middle part of our table, we're going to notice that we have peat filled in, HDPE, PVC, LDPE, polypropylene, and then along with our A, B, and C unknowns. And you guys were asked to put in sink or float. So we noticed for my P, all of them sank. So you should have gotten something like that as well. Hopefully all of your peat sank. My HDPE, I have 2 sinks and 3 floats. For PVC, very similar to peat, I have all sinks. And I want to bring attention to LDPE in that second column there. So maybe some of you guys experienced this and you weren't really sure what was going on. So you may have noticed right there, I have sink float. And I actually pulled this from students. So the sink flow indicates that in that particular liquid, that the plastic and the liquid probably had nearly the same or the exact same density. And so it neither sank nor float, just kind of hovered around in the middle. If that's the case, that's fine. Just go ahead and tell me what's going on there. You can put sink float, you can put stayed in the middle, whatever you observed is fine. What we're really looking for though is when it changes. So as long as we see that there is some change going on, you're okay. For polypropylene, I see that I had 1 sink and 4 floats. Polystyrene, I had 4 sinks and 1 float. And right away, you can already start seeing that there's a trend going on with our unknowns. Okay, so we see that our sinks, unknown A, were all sinks. So using my deductive reasoning there as my forensic science, I can kind of say right away that unknown A has to be either P, right, because that one had all sinks, or possibly it could also be PVC, which also had all sinks. So right off the bat, I'm going to be able to limit of those 6 plastics which one unknown A is. For unknown B, I see that it has 1 sink and 4 floats, and another one of my known ones also had 1 sink and 4 floats, so I see that polypropylene is possibly one of them. And then for unknown C, I see 2 sinks and 3 floats, And so if I look over there, I also get possibly HDPE or LDPE. So when we do our low density and our high density trends, that's where we're going to be able to see some of these trends. So the next part of this is going to be looking at the second table, which caused a lot of confusion. I think the first table was okay for most of you. So let's look at the second table. So what you want to do right now is you want to take your highlighter or pencil or pen or whatever you have at home during the zombie apocalypse, and you want to look for a sink float pattern. So where you're basically what looking for is where it goes from sink to float or float to sink, whichever how you want to look at that. And so what I did here is I went ahead and I highlighted over here with Pete. If we look, I highlighted the sink right there. Now there was no upper end of that, so I don't really know what would have happened if I had had another liquid, but I'm assuming that if I had had a liquid with a higher density, that I would have had a float on the other side here. So if you look here, I'm not going to have an upper end there. For HDPE, I find that I have my sink float there. PVC, similar to before. Excuse me. LDPE has that weird one. That's sink float. I'm going to go ahead and count that. Polypropylene has one here. And you can do the rest on your own. So what I'm basically doing is I'm looking for my upper and lower end. Now if you put this in order from low to high, you're going to be able to fill in the next part of your table pretty easily. So we see that. So let's shrink it back down. Okay, sorry for that awkward pause. Now what I'm going to do is I'm going to take my low density ranges of the ones that I circled, and I'm going to go ahead and fill them in. So that is going to be your sinks. Your sinks are going to be your low density range. So when we look over here for Pete, I'm going to put 1.37, and I am going to put that right there in that low density range. So my 1.37 is going to be my low end for Pete. Now on the sheet I gave you guys in your baskets, or on your green sheet, you were supposed to look up the actual density of Pete. So you see right here that I've done it here because I don't pay attention, but it's also over here as well. And so I know that Pete has a 1.38 density, so I'm going to make up my own high density range, and I'm just going to go 1/100th over what Pete actually is. So Pete is 1.38, so I'm going to say that my high density range is 1.39. I am only doing this for Pete and PVC, and the reason for that is because we did not test it with a liquid that had a higher density than Pete. So that's the only weird one there. Let's go ahead and look at HDPE. So for HDPE, I have a sink float right here. So my low end is going to be the sink. And so I'm going to put 0.92 for my corn oil. I'm going to transfer that down here. And I'm going to transfer the water, which is the 1.0 from my float, into the high density range. So right there. The actual density is what you guys researched, which was on your green sheet, or if you guys took it from my sheet. So if you didn't do this, you can go back and just Google what is the density for HDPE plastic. And then that's that number I have here. So if you're wondering where this number is from, it was from a sheet I gave you guys. You could also get it from your green sheet, or you could just research it. And so you're going to fill in your table basically with these sink and floats. So your low end is going to be your sink. So your low range is your sink. And your high range is your float. Okay, and that's going to take you all the way through to the end of this table. One thing I do want you guys to notice is that your actual density for your unknowns, we don't know what they are. That was kind of our job to find that out. So we don't really know what these are. So I went ahead and I left this part blank, or I just kind of put some squiggly lines in there so that I was telling myself that I didn't know that. And then also you are going to go ahead, and this is actually really important, you want to make sure that you are telling me, what do you think these plastics are? So make sure for sure you fill in that A, B, and C. What are these plastics? The last part of this worksheet is going to be on answering the questions. Explain how you determine the identities of plastics A, B, and C. And what I want you guys to be aware of is you need to be specific. How did you do this? Talk about how you created the ranges, the low and the high, that sink and that float range. Did you make any mistakes? So this is the part where you're going to get your points back. If you made a mistake somewhere, maybe you didn't wash the plastic correctly and you got the wrong float when it should have sank. You put the plastics out of order, you put the liquids out of order, anything like that. You want to just be very specific and, again, use your academic vocabulary. For part 2, you guys want to make sure that you are looking to see what other method would you have used. So instead of using liquids, could you use Archimedes' principle or the displacement? That's where you guys put it on the scale first. And then you guys use the graduated cylinder to see how much the water rises. If you choose to tell me about that method, that's fine. Just make sure you're using academic vocabulary. You could use diagrams. That would be great. It's going to give you a couple extra points there. So just be really specific on all of these things. I think that determines or takes us to the end of our video on this one. If you have any questions, please feel free to reach out to me using your Remind app or Loop Mail. And I'll see you guys later in video 2.